Good morning, students. Welcome back to Atul Academy. In this video, we are going to learn the trigonometric identities. It's a continuation of the previous one. We solved question number 5, 3 parts in previous video from exercise 8.4. Let us now start with the fourth part. I hope you all remember the identities. I'm writing them on the side. So sine squared theta plus cos squared theta is equals to 1. First one. Secant squared theta is 1 plus tan squared theta. Cosecant square theta is 1 plus cot square theta. So let us start over this. I'll start with LHS and I'll simplify it. You see over here, there is no square. We can't use all these. So we'll use the relationship between the ratios. So secant and cos are related. So secant is reciprocal of cos. So I'll use it over here. So 1 plus 1 by cos A divided by 1 by cos A. I can take an LCM over here. We can make it 1. So I have to make it like. So cos A. So it will be cos A plus 1 divided by cos A over 1 by cos A. I can also write this thing. If you have a confusion in this fraction part, you can change it in this form. Divide by 1 by cos A, which will be equals to cos A plus 1 over cos A into cos A by 1. These two cancels out, so we are left with cos A plus 1, or we can say 1 plus cos A. Both are same thing. Now you see this simplified form we got, and we can't simplify it further. So what I will do is, here I have to solve this RHS part also. Let's solve this RHS part over here. Sin square A divided by 1 minus cos A. Sin square A, so square we have, we can use it. What is sin square A? It's 1 minus cos square A divided by 1 minus cos A. This I can use an identity a square minus b square, which is a minus b and a plus b. So that's 1 minus cos A. Can cancel this out and I'm left with 1 plus cos A. So what all I have used over here is, I have used that secant A is equals to 1 by cos A. First step over here. Then nothing over here. Here I have used sin square A is equals to 1 minus cos square A. I've used this also. Another thing that I've used over here is a square minus b square is a minus b, a plus b. So I got my LHS is equals to RHS. Both are 1 plus cos A. Simplified form. I hope this thing is clear to you. Let's move to the next question. Next one is a very important identity to be proved. So let's see how we will do it. Now, LHS has cos sine 1, cos sine 1. RHS has cosecant and cot. So how do you get cosecant and cot? If I divide this whole, say, if I divide this whole by sine, what will I get? Cos by sine is cot, sine by sine is 1, and 1 by sine is cosecant. I got the thing that I want. So what I will do is I'll divide both the numerator and the denominator, both numerator and denominator by, I can do by sine. I'll do by sine only. If I do cos, I will get tan and secant. So no, I want cosecant and cot, so I'll do by sine A. Fine. So when I will divide by sine, only the LHS part I'm talking about. So it will be cos A by sine A minus sine A by sine A plus 1 by sine A divided by, again, cos A by sine A plus sine A by sine A minus 1 by sine A. So when I did this thing, what I'll get, cos A by sine A will be cot A minus 1 plus cosecant A divided by cot A plus 1 minus cosecant A. I hope the step is clear. Now, what I'm going to use over here is the second identity, which I said that cosecant square A or theta is 1 plus cot square A theta. So now I need this 1 actually. I will substitute the value of 1 in terms of these things. So I can say that cosecant square A minus cot square A is 1. So that is what I'm going to use over here. I'll just rearrange it. I'll write it like that. I'll take cosecant A first. Cosecant A plus cot A minus 1. This I'll write like that only. Cot A minus cosecant A plus 1. Now I'm going to change. Instead of 1, only in the numerator I'll change. Cosecant A plus cot A minus, instead of 1, I'll use this thing. Cosecant square A minus cot square A divided by cot A minus cosecant A plus 1. Now, this cosecant square A minus cot square A, which identity I can use over here? A square minus B square is A minus B into A plus B. So I'll write it like that. So it is here cosecant A plus cot A minus, I have cosecant A minus cot A minus B, cosec A plus cot A, it's A plus B, divided by numerator as it is cot A minus cosec A plus 1. Now there are two terms over here and I think these two are same. I can take them common. When I take them out, cosec A plus cot A, this is gone out. So what is left over here? Only 1 minus cosec A plus, not plus, plus I have taken common, will be minus cosec A minus cot A divided by cot A minus cosec A plus 1. Now let's open the bracket. When I open the bracket, it will be cosec A plus cot A, and I have 1 minus cosec A plus cot A. The sign will change, minus minus, it will change to plus, divided by cot A minus cosec A plus 1. Now when I see the denominator and the numerator, this part is not in the denominator, but if you see cot A, plus 1, that is also, and minus. Both the things are same. I can cancel the whole term. And I'm left with what? Cosec A plus cot A, which was the RHS. If we check cosec A plus cot A. I hope the step is clear. We just did what? I divided both the numerator, all the terms of numerator and denominator by sin A and changed them into cosec and cot. Then this 1 in the numerator, I only use the identity cosec square A minus cot square A, which I can open using the identity A square minus B square. So A minus B, A plus B. So I've written it like that, cosecant A minus cot A, cosecant A plus cot A, and then I've taken this cosecant A plus cot A common, as there were two common terms over here. When I took it common, I'm left with same terms in the numerator and denominator, and I cancel that. We got cosecant A plus cot A as the RHS. I hope this is clear. Let's move to the next question. The next question is a little easier one. Whenever we have roots, what do? We rationalize the denominator. Let's do the same thing over here. So LHS 1 plus sin A, 1 minus sin A. So I multiply numerator and denominator with the opposite sign, the way we do in rationalization. So this will change to now 1 plus sin A into 1 plus sin A is 1 plus sin A whole square, 1 minus sin A, 1 plus sin A. So this is again an identity. What is that identity? I can use A plus B, A minus B. So that will become A square minus B square. A is 1, so that root is on the whole term. So I have this thing. Fine. Now This 1 plus sine A whole square, square root is there. I can write it as 1 plus sine A only on the top. Denominator, I still have the square root. It's 1 minus sine square A. So 1 minus sine square A is cos square A. This is what I'm going to use over here. So I'll write it as cos square A. Now square root of a square is the number itself. So it will be only cos A. So I'm left with 1 plus sine A divided by cos A. So let us change this now. I can also write it as 1 by cos A plus sine A by cos A. I just separated it. The denominator goes to both the numerators. So 1 by cos A is secant A. Sin A by cos A is tan A. And this is the RHS that we have to prove. So we got this thing equals to secant A plus tan A. What I have done only is to rationalize the denominator with opposite sign. So it will become 1 plus sin A whole square. Denominator 1 minus sin A into 1 plus sin A. But square root of square of a number is a number itself. I wrote it as 1 plus sin A only. Denominator is a square minus b square entity being used. Now 1 minus sine square A is cos square A. So converted it to that. Square root of cos square A is only cos A. Then I separated the numerator denominator and I got the secant A and plus tan A. I hope this is also clear. Let us move to the next question. Next question is also very easy. Let's see what we can do over here. Sin theta minus 2 sin cube theta, 2 cos cube theta minus cos theta. We see that in the numerator sin is there in both the terms. Here cos in both the terms. Let's take it common. So I can take sin theta common from the numerator. 1 minus 2 sin square theta. Denominator also I'll take cos theta common. So it's 2 cos square theta minus 1. I can either change this sine square theta now or this sine cos square theta. So I know sine square theta is 1 minus cos square theta. So I'll change in the numerator only. Keep it like this only. Sine theta by cos theta. This will be 1 minus 2. Sine square theta is 1 minus cos square theta. Denominator as it is, I'm writing. Now, let's open the bracket. It will be sine theta 1 minus 2. 2 into 1 is 2. Then minus 2 into minus cos square theta will be plus 2 cos square theta divided by cos theta 2 cos square theta minus 1. 1 minus 2 is minus 1. So I'll write sine theta minus 1 plus 2 cos square theta divided by cos theta 2 cos square theta minus 1. Both the things are same only. This is minus 1 plus 2. This is 2 cos square theta minus 1. So I can cancel this thing. So I'm left with only sine theta by cos theta, which is tan theta, and that was the RHS only. I hope this tip is also clear. I just took sine theta common from the numerator, cos from the denominator, and changed this sine square theta into 1 minus cos square theta. Open the bracket, simplified it, and just cancel. We can also change this cos square theta into 1 minus sine square theta. It will be, this term will then become similar to this term, and we can cancel it, and we are left with only sine by cos, which is tan theta. I hope all these 4 parts are clear to you. We have finished till 7th part. So trigonometry students, you need to keep practicing. You have to do multiple times identities. These ones also, plus practice more, so that just by seeing the question, you will know what step you have to do, where you have to convert, what you have to prove, how to do. So I hope everything is clear. I'll come up with another video in which we will do other parts of the question. Thank you for watching the video.